Okay, let's just dive right into this. Welcome to today's Explainer, where we are mapping out the ultimate, complete blueprint for modernizing your Laravel stack. We're talking about moving way beyond the basics to achieve true enterprise-grade scalability.
Because, let's be totally honest here, it's one thing to build a working app that runs beautifully for a handful of users, but scaling that up to handle thousands of concurrent users, well, that requires a fundamentally different architectural mindset. You can't just throw more server power at it. You literally have to engineer the efficiency right into the code. We're going to treat this like building a skyscraper. And here is our blueprint for that build. 1. The modern foundation. 2. The engine room using Octane. 3. The wiring with Reverb. And 4. The inspection using Pest.
Let's start with Phase 1, the modern foundation, lean architecture, and smart UIs. Starting right on the ground floor, Laravel 11 introduces a radical minimalist structure. By ripping out legacy boilerplate like that traditional HTTP kernel and relying much more heavily on auto-discovery, the framework gives us a significantly cleaner, more predictable base for our enterprise modules. It's all about reducing cognitive load, giving your team a totally streamlined starting point.
On top of that foundation, you face a critical UI decision matrix. Now, the debate isn't about which one is inherently better, it's about what fits your specific use case. You'll want to choose Livewire for a back-end-driven approach that gets you to an MVP incredibly fast, which is absolutely perfect for CRUD operations and admin panels. But you should opt for Inertia if your team needs high front-end flexibility, React or Vue components, and those snappy SPA-like interactions with super low post-load latency.
Once your UI is locked in, you have to feed it data efficiently. Let's talk about the number 12,500. We've all accidentally melted a server trying to solve an N+1 database problem, right? Imagine eagerly loading 12,500 login records into memory just because you want to display the last login date for 50 users on a single dashboard page. It is a massive waste of resources.
Well, by utilizing Eloquent subqueries, you can solve this incredibly elegantly. Instead of eager loading thousands of full Eloquent models, you just push the heavy lifting down to the database layer. You select just the foreign key or the specific date you need as a dynamic attribute right inside your main query. This perfectly satisfies both low query counts and low memory usage, all without having to resort to messy, manual caching. It's a real game changer.
And you can optimize this data foundation even further by using clean, advanced Eloquent filtering techniques. Leveraging methods like whereany, combined with the like operator, allows you to build really robust semantic search functionality directly into your controllers. No sprawling, complex database logic required.
All right, moving on to Phase 2, the engine room, performance optimization with Octane.
Let's see how strapping Laravel Octane to our freshly optimized queries takes raw performance to the absolute next level. So, with traditional PHP, the entire framework basically reboots for every single request. Octane completely changes the game here. By keeping the framework loaded in memory using application servers like Swool or Roadrunner, you can see performance improvements of up to 20 times, especially for your API endpoints. But this in-memory architecture demands some pretty aggressive optimization. Since processes live on, you absolutely must perfectly tune your worker counts based on whether your app is CPU or I/O bound. And even more importantly, you have to strictly enforce a max request limit. So, for example, rebooting the worker every 1 to 5,000 requests. This proactively prevents silent memory leaks from bringing your entire application to a grinding halt. You also have to manually clear out persistent singletons and force garbage collection. Okay, Phase 3, the wiring, scaling real-time with Reverb.
So with our engine roaring and memory tightly managed, we need to run the wiring for our real-time systems. And managing thousands of persistent connections introduces massive headaches for enterprise apps. Think about it. You'll be dealing with resource-eating zombie connections from mobile users dropping off on stable networks, and super frustrating race conditions where a WebSocket state update arrives before your HTTP post request even finishes processing.
To solve this mess, we implement a highly distributed flow. Picture a Next.js front-end client listening securely via a custom echo hook. Over on the back end, Laravel broadcasts the event to Redis. Redis then acts as this lightning-fast bridge, instantly syncing that state across multiple Laravel 13 Reverb WebSocket servers.
And this brings us to a rule you really need to live by. Always use Redis for horizontal scaling, even if you're just starting out with one server. If you want to avoid hitting a brutal wall the exact second your traffic spikes, Redis is the absolute non-negotiable backbone for routing your real-time messages. It lets your Reverb instances scale horizontally without ever losing track of which user is connected to which server.
Finally, Phase 4, the inspection. Bulletproof testing with Pest.
Before we open this newly built skyscraper to the public, we need to guarantee the building won't collapse under pressure. A truly robust test suite understands the dichotomy between unit tests and feature tests. Unit tests run without the application container, so they are lightning fast because they test pure logic. But feature tests boot the full application, catching those real-world integration bugs. You should heavily prioritize the latter, aiming for roughly a 3-to-1 ratio of feature-to-unit tests to guarantee your database, routes, and HTTP layers actually work together seamlessly.
Now, to keep these feature tests from becoming incredibly brittle, remember the golden rule. Only mock at the boundaries of your application. Don't over-mock your internal domain logic. Let Laravel's elegant built-in facade fix intercept things like emails and queues, and use mockery strictly for third-party dependencies injected via the service container.
Pest 4 actually takes this a step further by allowing us to run incredibly fast architecture tests. These analyze your code structure by reading the abstract syntax tree instead of running the code. Meaning, you can instantly and automatically fail the build if a developer accidentally leaves a debug statement in, tries to use an insecure function like eval or MD5, or tries to sneak a raw Eloquent query directly into a controller instead of using your proper service layer. As we wrap up this explainer, I want to leave you with a provocative thought about mutation testing. Code coverage only tells you a line of code was executed, not that it was actually tested well. If Pest deliberately breaks your source code's logic, like flipping a greater than sign to a less than sign, and your test suite still passes, do you really have the coverage you thought you did? Think about that as you build your next enterprise feature. Thanks for joining me today.